Hi, I'm Dave from Estuary, and I'm here to talk about how we can apply some of the benefits of the modern data stack to the world of streaming. The modern data stack has greatly improved accessibility of data, especially to less technical practitioners. We tend to think of it as a set of vendors and tools, but in reality, its true value stems from the fact that it enables simple insights to a new class of users. At a high level, it introduces the ability to connect data from SaaS and technology sources to places that you can analyze it with just a little bit of SQL, like a data warehouse. Contrasting this to the streaming world, the situation is very different. Instead of products, we're presented with pieces of open source technology that all need to be managed and maintained as infrastructure. The skill set required is vastly different. On one side, less technical users can easily generate business insights, and on the other, you need a team of seasoned engineers just to get started. Generalized ELT has made it possible to extract data from SaaS systems without writing code that integrates with each system's API. Airbyte, for example, has developed an amazing protocol to unify the many source connector projects that exist in the ecosystem. Furthermore, Airbyte offers a simple configuration-driven CDK or connector development kit that you can get started on building connectors without even writing code. Streaming still requires bespoke development. Kafka Connect offers connectors to some systems, but most are paid and proprietary, and the scale of connectors is very different than what's available in the batch world. dbt introduced an extremely powerful abstraction for defining a data product or view one time and then using it over and over in a repeatable way. This innovation made it easy to define views in a central location and then build off them for more powerful chain data sets. Compare that to streaming, where every transformation is bespoke, and it's a bespoke application that engineers have to run and maintain and keep on going as time goes on. There is no such thing as a streaming DAG unless it's built, managed, and maintained by a specific organization. The modern data stack's innovated towards data sets that are discoverable to the broader org with clear chain of custody to the broader org. And you can understand how a data product came to be. Individual users can derive their own insights in a data warehouse and get pre-canned ones through dashboards, all with fine-grained usage controls. Again, compared to streaming, where custom engineered applications are essentially black boxes. Asking new questions is incredibly hard, and there's not really a notion of quick insights, but instead longer-lived data products that are set up and then used over time, and maybe as dashboards, but most likely as an actual data product. The streaming ecosystem is rife with what we call buffers. So Kafka still defaults to a one-week retention. So does Google PubSub. Kinesis only has 24 hours. The best practices for these products force you to spill data somewhere else, like a data lake or blob storage. And then you need to backfill. You'll need to take for a new view or use case, you'll manually stitch the historical data and the real-time data together. This sucks and simply doesn't work for users who will absolutely avoid it. And instead, they'll turn to the modern data stack. The streaming ecosystem needs to think in terms of data products, the way that people do. And they need to have a data-centric perspective with automatic backfills. Fancy UIs that allow you to set up integration using OAuth and GUIs make it really easy to get started. It's possible to show value with the modern data stack in 5 minutes using such paradigms. And in streaming, that's just not the case. You're going to be writing code, releasing and custom developing that code. Finally, both the modern data stack and streaming require stitching multiple technologies together that enable an end-to-end use case. For the modern data stack, all those technologies have managed options, and that makes it pretty turnkey to integrate them. And you'll know that things will just work together. While streaming does have some managed options, there's nothing that just works end-to-end. For a full use case, spending time on custom development, as well as managing services and stitching them together for ongoing maintenance is going to be required. So this aspect generally means that streaming systems are reserved for larger teams that can continuously devote resources to their care. They can be inaccessible to startups and even SMBs. So there's a lot of gaps here between the two worlds on the surface, and putting them together seems like it might be an intractable problem. But let's dive into what can be done. So connectivity is a good place to start. There's been a ton of great work in the space in the past 5 years. And a good place to start thinking about is how we can leverage that work that's done in the batch space instead of trying to reinvent the wheel with a totally new protocol for streaming. So at its core, let's start with Airbyte. Airbyte connectors work with as Docker images. They read from standard in and they write to standard out. The only reason that they aren't inherently streaming is that those Docker images exit. If we just decided to run them forever instead of exiting, they'd actually be, in fact, streaming connectors. So this would buy us two of our goals. The first one is that we'd get open pluggable connectors. Every single Airbyte connector could be supported in a streaming context. And then the second is that we have configuration-driven captures. The latter comes naturally because the Airbyte protocol plugs directly into JSON forms. Most data tooling uses periodic batch processing, which means copying subsets of tables or even full tables from one place to another now and then. Then we'll go on to process multiple cascading views over that data and have to either reprocess the world or manually stitch together many incremental updates into a single holistic view. This is either costly from a machine standpoint or a developer standpoint. By comparison, this is a place that streaming actually shines a bit, and continuous processing focuses on cascading updates, things that have changed from the source system to the destination system. That may be built over the data. Stream processing leans on techniques that process events. So often we don't have broader context, and we must be clever about how we manage state. When connecting a stream of dataset updates to an end system, like a database, that system would often be really good at managing state. In fact, they're designed for that. So we should leverage that capability set. Here's an example of how we can actually put that into action. Leveraging the database's understanding of state to maintain an exact aggregation with maximal efficiency. You can see what's happening here. So we're starting by generating a new row of data, and that row of data goes into the runtime. The runtime queries to understand what already exists in the database, and then it reduces it together and pushes it back into the database. So what you're getting at is you're managing a fully aggregated state within the database, so it's maximally efficient. While the transaction commits, we're actually able to combine more and more data and offer a natural rollup because we have back pressure from the natural latency of the database. Doing so lets us build more and more sophisticated and low latency views right in that data system. We no longer need specialized data systems like ClickHouse or Druid or Pinot, which deal with vast quantities of streaming data. Rather, we can focus on using a system that's best for the job, like Postgres or even maybe a Google Sheet. So we've gotten about halfway there, but let's stop here since we only have a 10-minute talk, and we'll talk about the rest really quickly. As you can imagine, a fully managed service can handle most of the rest of the points here. And I work at Estuary, so we're probably heading towards the direction of a shameless plug. Estuary does offer these options, and you can check it out and sign up for a free account at estuary.dev. Thanks for checking out our talk.